Page 2, discuss the skewness. Well, we found that the mean of this sample, so I should be doing this mean, was where was it? 0.744, and we found the median was 0.75, and the mean is pulled towards the skewness, and so that's smaller than this, so it's skewed to the left. But only slightly, because these are really close. And you can kind of see it on this histogram I made. This means here, and it looks like there's a little bit more tail on this side than there is on this. You can see it slightly in the box plot, so you could have mentioned this also. This one is stretched out a little bit more. These whiskers are about the same, but it's stretched a little bit more from the middle than it is from this side, on that side, but very lightly. 95% confidence interval for the mean of the population. The mean of the population is in the interval of the mean of the sample, plus or minus 2 for the 95% of the population standard deviation, but we don't have, yes we do have that. No, this is a sample. So we use the sample standard deviation divided by the square root of n. So that would be the mean of the population, or the sample, was 0.744 plus or minus 2 times the standard deviation, which we found to be 0.142, divided by the square root of n, in this case 15. So we get 0.744 plus 2 parenthesis 1 0.142 close parenthesis divided by the square root of 15, and I get the higher end of the confidence interval, 0.817. Population mean is below that and greater than the same thing here, but with a minus, and that would be 0.671. So 95% chance that the population mean is somewhere between these two numbers. And a 75% chance, that would be a narrow one. I have to use a different number than 2 for 75%. And I would look up on my table for the z-score for 75 only, not 75, half of 75, which is 37.375. 375 is really close to that. That's 1.15. So I would use 0.744 plus or minus 0.115, or 1.15, times the standard deviation, 0.142, divided by the square root of 15. So bring this back and do the one with a plus and change the 2 to 1.15. 1, insert 0.15. And I get the upper to be 0.786. The mean of the population is a 75% chance to be between that and this one with a minus. 0.702. Okay. And number 2. Suppose the average wingspan of a species of hummingbird is 2.5 inches. So center is 2.5 with a variance. So we're knowing the population variance to be 0.36, which means the population standard deviation is 0.6 if I take the square root of that. And so now we're going to do a 9-bird sample. So we want to look at the sample distribution, which is narrower. It should have a mean of same as the population, close to it, the sampling distribution, and its standard deviation, the standard deviation of the sample means, should be 0.6 divided by the square root of the size of the sample, which is 9-bird sample. So you'd have 0.6 divided by 0.2, by 3, which is 0.2. So the standard deviation of this here is 0.2, so that'd be 2.7 and 2.9 of all the means of 9-bird samples, and 0.3. So 9-bird sample that has an average wingspan of at least 2.7 and more. Well, this is 50% for this much, and this first one, since that's one standard deviation over, this is going to be 0.3413, so it's going to be 0.5, the half of this, minus the 0.34, which comes out to be 0.1587. Okay.